Hi there. In this video, we're going to discuss a paper on Cassandra, a decentralized structure storage system. This paper was published by around 2009 by Avinash Lakshman and Prashant Malik, both former employees of Facebook. Moving on to the next slide. Let us understand the motivation behind Cassandra. It all started at Facebook. So we all know that Facebook has billions of users and at peak hours there might be hundreds of thousands of users available online, which are posting and retrieving data from tens of thousands of servers. Um, uh, so the amount of data that all these users are generating is very high. Not only that, but the since the data here we are dealing with a huge amount of data, retrieval also becomes very critical. Also, when we are dealing with such a distributed network with thousands of servers, we have to take into account the failures of the servers, how dynamically they can be replaced. Scalability is also one of the important factors here. As the number of users and the amount of traffic increases, we dynamically would want to add more nodes to it. So these are important factors which were considered for all these requirements. The solution that Facebook came up with was Cassandra. Cassandra is a distributed storage system for managing large structured data across multiple nodes. It provides very high availability without a single point of failure. Highly scalable. It was designed to work on cheap commodity hardware and handle high write throughputs without sacrificing read efficiency. Basically, for read, it internally uses consistent hashing, which we will be discussing later on. So no matter how many number of nodes you keep on adding or how many servers are there, the read will always be asymptotically the same. Primarily, this was used in inbox search. So basically, when you log in into Facebook, then if you go to the messenger where all your chat messages over the past so many years have been stored, then for a particular user, if you go and search, then these search results and everything are being carried out by Cassandra. Although if you do a little bit of search, then we can find out that in 2010 itself, Facebook stopped using Cassandra, and instead they had made their own implementation of messaging platform on Edge base, and later on Cassandra was being used in Instagram instead. Um, Now, before diving into the specifics of Cassandra, let us discuss some of the related work. Um, in distributed file systems, we have Ficus and Coda, which replicates the file for high availability at the expense of consistency. Farsight does not use any centralized server. Again, this is a very important concept which is gaining a lot of momentum. So rather than having one centralized server where you maintain all your important data, and if it fails, then it becomes very critical. Rather than that, if we have all the nodes at the same level, then you are basically distributing your risk. This is again a very important concept, but not within the scope of this paper. Google file systems maintain a master with entire metadata, and the data is split across in chunks across the nodes. The master is made fault tolerant using Chubby. Distributed relational database like Bio, it allows disconnected operations and provides eventual consistency. So basically, when you say that it allows disconnected operations, then of course there will be some conflict resolution scheme which it will employ later on. Dynamo allows read and write operations even during network partition. It uses a gossip protocol for every node to maintain details and information about every other node. It's not mentioned in this paper directly, but Cassandra also uses internally the gossip protocol. At least the later version of Cassandra does use it. So gossip protocol, it's nothing but like a node makes a datagram which we call as the gossip datagram, and it randomly sends it to servers within the network, and those n servers in turn append their own data and send it to randomly chosen n more servers. So that's how every node in the network knows about every other node within the network. Um, conflict resolutions, conflicts are detected using vector timestamp. Vector timestamp is nothing but a way to serialize the request as to which one, how to sequence the request. Big table provides both structure and data distribution, relies on distributed file systems for durability. Moving on to the next slide. So let us understand the data model in Cassandra. A table in Cassandra is nothing but a distributed multidimensional map indexed by a key. The key in this case, although it doesn't have a size restriction, but it's a string usually of size 16 to 36 byte long. The value is nothing but a highly structured object. Any row operations in Cassandra are atomic per replica, no matter how many columns are involved, or whether it's a read or a write operation. Columns in Cassandra are classified into simple column family or a super column family. Typically, this is how a table in Cassandra can be visualized. Moving on to the next slide. The API is exposed by Cassandra insert, get, and delete. In insert, we need to pass the table, the key, and the row mutation. Row mutation is nothing but the data that we need to insert. For get, we need to pass the table, the key, and the columns that we need to fetch. The column name here in turn would mean can be a simple column with a simple column within the column family, or it can be a column family or a column within a super column. For delete, we need to pass the table, key, and the column name. Moving on to the next slide. As far as system architecture is concerned, we will be restricting ourselves to the following properties: partitioning, replication, membership, failure handling, and scaling, and how it has been implemented in Cassandra. All these modules work in synchronously to handle the read and the write request. A read-write request, basically when it comes in, it is being handled by any of the nodes, and using hashing we identify where the replica of this particular request or this key is present, and accordingly the request is being routed. For write request, for the write request, the system routes the request to all the replicas, and it waits for the right quorum. For a read, based on the consistency settings or the requirements, either we send the request to all the replicas and wait for the read quorum, or redirect it to the nearest replica to get the value. Moving on to the next slide. Partitioning, one of the key features for Cassandra is to scale incrementally. So basically, if there are nodes which are having a lot of nodes, and if you want to dynamically add new nodes, then those nodes will be dynamically be able to shed or take some of the loads from the existing servers. Dynamically partitioning in Cassandra is done using consistent hashing. The advantage of consistent hashing is that the arrival and the removal of a node, it affects only the neighboring nodes. Replication in Cassandra is used for high availability. Replication policies available are rack unaware, rack aware, and data center aware. The last two being a little more complex. For example, rack aware, in the sense it means that all the replicas should not be in the same rack, so that if there is some problem in that particular rack, then still the replicas are available elsewhere, and it can be the data can be retrieved. Similar things go similarly for data center. All the replicas should not be available in the same data center. Rather, the replica should be distributed across. So at the startup of the using Zookeeper, one leader is being elected, and all the other nodes basically contact this leader to get a certain range for which they should be maintaining the replicas. And all the metadata regarding the range of all the nodes are maintained not only in the Zookeeper but in other nodes as well. Moving on to the next slide. Membership in Cassandra is based on Scuttlebutt, which is a very efficient gossip-based mechanism. The CPU utilization by this Scuttlebutt is quite efficient. Gossip channel is also used for failure detection of any other nodes. Bootstrapping. Now, at the startup of the node, it basically chooses or is being assigned a random token, which in turn determines its position in the ring. Now, this random token is stored locally, and plus, if there is a centralized server like a Zookeeper, then it is being shared with the Zookeeper as well. At the startup, the new node, either it's been provided with some configuration file, or the new node basically contacts the Zookeeper to get some initial contacts, which are also called as seeds. Moving on to the next slide. Scaling the cluster. A token is assigned to a new node which decides its position in the ring. Uh, New node is added such that it elevates the heavily loaded node. So let me give you an example here. So basically, if suppose there are two nodes which are handling the range from 1 to 100, then and if you want to add a new node, then basically what it does is the range itself is being broken down. It's been shared across the all three nodes. So this is what scaling is. It's nothing but splitting the range that some other nodes previously were responsible for, something that we discussed. The node giving up the data streams it using the kernel copy techniques. Kernel copy techniques, basically it means that CPU is not involved in this copy, so you basically save the CPU cycles. Local persistence. As far as local persistence is concerned, Cassandra depends upon the local file system. The write operations, it involves a write to a commit file post which updates in the in-memory data structure. Once the in-memory data structure exceeds a certain size, all the contents are dumped into the disk. Read operations. First, queries the in-memory data structure. If not found, then then search the files in the disk, starting from the newest to the oldest. To improve the performance, Bloom filters are used to prevent the lookup in the files which do not contain the key. Moving on to the next slide. Few of the important pointers as far as Cassandra is concerned. The main modules, the partitioning, membership, failure detection, storage, and persistence. All these modules were implemented in Java. Internally, it uses non-blocking I/O. All the control messages uses UDP protocol, the gossip datagram that we spoke about earlier. All the data is indexed based on the primary key. The data files on the disk are broken in sequence of blocks, and an order is also maintained starting from the newest to the oldest. The recent data is kept in small data files which are later merged into larger merge files. Cassandra, like we spoke early at the beginning, that it is being used in the Facebook inbox search. So in this, per user index is maintained for all the messages that have been exchanged between the sender and the recipient. Two kinds of search features: the term search and interaction, the name of the recipient. It internally, it also uses intelligent hook for caching. So for example, when as soon as I click on the search, I'm already in the chat message for one of the recipient, and I click on the search. then all the data, there is a hook which sends a message to the server side, and all its data is already being brought into the main memory. And once I do the search and send the request, the data is already meanwhile in the main memory, so it becomes more efficient. So that's the intelligent hook for caching. That's all we have for this particular paper. See you until next time. Thanks.